This video tutorial is the fourth in a series of 6 on working with tables, graphs and equations for junior school. Okay, so in this video we're going to look at drawing a graph when we have an equation. So a couple of things that we have to think about. We look at this equation here that we're going to graph. We have got the general equation y equals mx plus c, m being our multiplier or our constant difference. So if we were plotting coordinates and we had a multiplier or constant difference of 3, like we have here, the graph would be going up 3 each time, and that's exactly what happens. Our multiplier, it's the gradient of the graph, makes it go up 3 each time. So if we write a general rule for the gradient, we have up 3 and we go across 1, which is the same as 3. So we have this rise over run is the rule that we have for gradients. We rise 3, we run across 1, or whatever the gradient or constant difference is. So the next part of the equation is the piece on the end, the plus something or the minus something on the end. That's the y-intercept. Now if there was such a thing as a zero pattern, a little bit of imagination there, that's what the y-intercept is. It's what, if we had nothing, if x was nothing, what would y's value be? So let's have a look. Let's substitute 0 into here and see what happens. Y equals positive 3 times 0 minus 4. So it's equal to 3 times 0 is 0. 0 minus 4 is minus 4. So you can see our y-intercept is our 0 pattern, so when x is 0. So let's go ahead and plot that piece first. That negative 4, the y-intercept, right there. Now, our gradient is 3. We go up 3 for every one across. So let's do that. 1, 2, 3 and run 1. 1, 2, 3 and run 1. 1, 2, 3 and run 1. And we can keep going and keep going. So then we put a ruler on it and we rule a straight line through all the dots, and it should be a straight line, and it could theoretically go on forever in both directions. Not so much in a practical situation, but for a general equation, the graph could go on and on. Okay, so, and we'll do it on the same axis, and I'll use a different colour. Rightio, so let's look at y equals, we'll do a negative one this time, negative 2x plus 5. So our y-intercept here is 5, and our gradient is negative 2. So the m, the gradient, is negative 2, and the c, the y-intercept, is 5. So let's do the y-intercept first. So there it is at positive 5 this time. And our gradient, remember gradient is rise over run. So we rise and run. Negative 2 over 1. Now we need to have a over 1, it's the same thing. Negative 2 is the same as negative 2 divided by 1. So we, negative 2, remember, we're going downhill. So from this point that we already have on the graph, we're going to go down 2 and across 1. Down 2 and across 1. We can see it's making a downhill line. Down 2 across 1. We get our ruler, put it on, rule a nice straight line through all the points, and theoretically it should go on and on forever. Nice tiny little arrows on each end. All right, one more just to be sure. We'll get a blue one this time. So y is equal to, let's do a fractional gradient, like we did a half in one of the previous clips. N, it is going to be the x-axis, but it could just be n as well. Let's keep it a bit simple just for now and keep it as an x. Okay, so y equals half x plus, I'll find something that's not going to crash on the graph too much. We'll do minus 1. Okay, so our c is equal to minus 1, and our gradient is equal to a half. We've already got a rise over run, so that's great. So let's start at our y-intercept, -1. We rise 1, run 2. Rise over run. Rise 1, run 2. Rise 1, run 2. 1 up, 2 across. Put our roller on. It should be a nice straight line. If it's not, we've made a little mistake somewhere. Arrow on each end. We're done. Okay, so in our next tutorial, we're going to look at doing this in reverse. We're going to have a graph and we're going to work out what the equation is for that graph. So that will be part 5 of 6.